going to talk about end behavior, finite differences, and transformations. So end behavior is we're going to be given a function, and I want to describe what the function is doing as x heads out towards positive infinity. So here's the x-axis, and as I head out to the right, my numbers get bigger and bigger, so that's no positive infinity. And if I head to the left, my numbers are getting larger and larger negative numbers, and that's negative infinity. So what I'm going to do is I'm going to go out to the right, and then I'm going to look up or down to see which way my function's going. And my function, which is the y-axis, if it's going upwards, is heading towards positive infinity, and if it's heading downwards, it's heading towards negative infinity. And what the end behavior is just where's the function heading as x becomes larger and larger, and as x becomes smaller and smaller, numbers are larger negative numbers. So I'm just going to write down what I just said so you have it into the note. So the end behavior describes the function as x approaches very large positive numbers. So ultimately, mathematics takes English phrases and puts them into symbols. So instead of writing as x approaches very large negative numbers, we write as x. This arrow means approaches, and positive infinity means very large negative numbers. So I want to know what the function's doing as it approaches very large positive numbers, and as x approaches very large negative numbers. So again, x approaching negative infinity means that's approaching very large negative numbers. So ultimately what I want to be able to do by the end of this, or what I want you to be able to do, is look at a function, whether it's a graph or an equation, and figure out where the end behavior is heading towards. So example, describe the end behavior. Oops. So here's my function. And the only thing end behavior is where's my branches of my function heading towards as I'm heading out towards the positive and the negative x direction. So I want to answer this question here. As x approaches positive infinity, what value is my function approaching? And as x approaches negative infinity, what value is my function approaching? So this one here, right? So when I say as x takes on larger and larger numbers, remember this, the red is the function value. So if x is this number, my answer, what if I sub this in, I'd get this answer. If x was here, I'd get that. If x was here, I'd get that. If x is here, I'd go down. So we're ultimately, as I take on bigger and bigger x values, where's my function heading towards? Okay? Right, we write down negative infinity. And on the other side, as x takes on larger and larger negative numbers, where is my function heading towards? In positive infinity. So hopefully pretty straightforward stuff. You just look at the right side and look to see if your function's heading upwards or downwards. Look at the left side, look if it's heading upwards or downwards. Any questions on that? Okay. So I want to answer the exact same question, but this time I'm going to use the equation instead of the graph. The graph's hopefully easy to read off. The equation is done with a little bit more effort, but the concept should be fairly simple. So that's the question I'm asking. When I'm asking for end behavior, I'm asking you to fill in these two answers here. Okay? So whenever you're given an equation to define the end behavior, you look at the degree of the polynomial, which is 4, and you use that term in order to determine. So the x with the biggest exponent determines the end behavior. This is the only thing I really need to worry about. All the other ones I can just ignore. Okay? And then what you're going to do in your head or mental math, write it down on a piece of paper. If I take a very large negative number, because that's what this means, as x approaches negative, if I take a very large positive number, and I put it in for x, if I put it to the power of 4, it's just going to be a bigger positive number, right? And then when I take that and multiply it by a negative 8, it's just going to become a really big negative number. And if I keep doing that, it's just going to become really big negative numbers, so it's heading down towards negative infinity. If I do that on the other side, if I take a really big negative number and put it to the power of 4, a really big negative number to the power of 4 is going to be a bigger positive number. And when I multiply it by negative 8, it's going to turn it back into a negative, so it's heading towards negative infinity. Does that make sense? Okay. So again, if I ask for the end behavior for a question like this, you're asking, as x approaches positive infinity, where is my function approaching? And as x approaches negative infinity, what is my function approaching? So in this case here, what term defines the end behavior? Here. Right. So this is the one that determines the end behavior. Everything else we could ignore. Right? Take a big positive number, put it to the power of 3. It's still going to be a big positive number. Multiply it by negative 7. It'll just become a negative big number. Negative infinity, if I take a really big negative number, put it to the power of 3, that's going to be some negative answer. A negative times a negative is a positive. So that side is going to head towards positive. Does it make sense to what I'm doing? Okay. So if I look at these two questions here and make some generalizations, whenever you have an even degree polynomial, even because 4 is an even number, the end behavior is always going to be the same. They're always going to head off in the same direction. Whenever you have an odd degree polynomial, the end behavior is always going to be opposite. They're going to head off in opposite directions. Okay. So let me just write that down so we have that in our notes. So even degree polynomials have the same end behavior. Odd degree polynomials have opposite end behavior. No, if this guy here was positive, right? The only difference is this guy would have headed to positive infinity, this guy would have headed to negative infinity. Right? When it says opposite end, it just means that one side's going to go to positive, one side's going to go to negative. Okay? That's what it means. Always. Okay. Any questions on end behavior? Okay. So the next thing you're going to be responsible for knowing is finite differences. And you actually did a lot of this in grade 9. So we'll just do an example to illustrate what you need to know for finite differences. Example, determine the degree of each function. Okay, so I give you a function 6x cubed minus 10x to the fifth plus x to the sixth, and then hopefully you would tell me the degree is here. What's the biggest exponent? 6. Pretty straightforward stuff. Remember, the degree of a polynomial function is the highest exponent in the expression. It becomes a little bit more difficult when I give you the function as a set of points. So the first point on the function is -3 and 173. The second point is -2 and 70. Then -1 and 19. 0 and 2. 1 and 1. And 2 and -2. Okay, so this is where the finite difference is come into play. So the finite differences are finding the first differences, which you did a lot in grade 9. And when you found the first differences, and the first differences was constant, what did that tell you about the function? See? It was linear. Right? All we're doing today is, if you find the first differences and they're not the same, then you move on to the second differences. If the second differences are the same, then what do you think it is? Yep, quadratic. And if the third one, then it's cubic, and then the fourth one is quartic. Okay? So how do I find the first differences? So remember, or maybe I'm telling you for the first time, that little delta, it's not a triangle, it's a delta, it's a Greek letter, represents differences in mathematics. So the first difference is, how do I find them? Yeah. Yeah, actually, it should be the one below it, subtract the one above it. Right. If you do it in the opposite order, you're still going to get the number the same, but you're going to get the sign different. Okay, so it has to be the one below. So 70 subtract 173. So you do that, which I've done for us. -103, and that, subtract that, is -51, then -17, -17, -1, and -3. So obviously those numbers don't match. If they don't match, you move on to the second difference. And you just keep going until you get all the numbers match. On a test, if you're doing this and it doesn't match by the fourth one, you probably did something wrong. Okay? So 52. So remember, on a test, you have to subtract them in the correct order. That obviously isn't the same. Go to the third one, and if the third one works out, which this case it does, then because the third difference is constant, then you can say the degree of this polynomial is 3, which ultimately means it's a cubic function. Any questions on finite differences? Okay. The next thing that you need to know is transformations. Now, in this guide, the first guide, they have a lot of pages dedicated to transformations. Okay? What I'm going to go over here is what I expect you to know for the test. Transformations. I can take any function and I can put it through various transformations by adding numbers in front, inside, and at the end of the function. Now, I'm not going to write down every single thing that the A, B, C, and D do, because we've done plenty of this. I just want to remind you that the A and the b values affect the range, which means it does things vertically. Okay? So the b moves things up or down. The a stretches things or compresses things or reflects things vertically, which is the range. The c and the d values affect the domain. So it does all of that stuff, but it does it left and right. Okay, so, but it actually does the opposite of what the numbers look like. So the a's and the b's do exactly what they look like. So if this was -7, that means everything will move down 7. If this was 3, that means you would stretch it by 3. But if this was -7, what does it actually do? Yeah. Right, it moves it to the right. And if this was 3, what does it do? Yeah. It compresses. Okay, so remember the outside does exactly what the numbers look like they should do. The inside, it does the opposite of what you think it should do. Okay? So you will be responsible for answer. This is the only thing. There'll be no graphing or transformations on the test whatsoever. You'll be responsible for something like this. Example, state the transformation. On the graph of, so this is my parent function. This is my original function, x cubed. And then I'm going to put it through the following transformation. So basically, your goal is to tell me what each one of these parameters do to the original function. Okay? So I'm going to break it down into the 4 parts. The a value, I want you to treat it as 2 things. If it's negative, talk about what the negative does, then talk about what the 2 does, and then we'll talk about what this -1 does, and then we'll talk about what this -4 does. So what does the negative do? Yeah? Okay, so which line? X equals y? X. You write the x-axis. Okay? So the negative flips it, inverts it, or reflects it in the x-axis. Because remember, everything outside does things vertically. Okay, so it's reflecting at the x-axis. What does this 2 do to it? Yeah? Excellent. That's exactly what I want to see. I want to see which direction it is. If you don't put that in, you won't get a mark. So it's a vertical stretch. And then this is important too, by a factor of 2. You have to tell me by what it's being stretched by. Inside of the bracket, that -1, what does that do to the function? Perfect. Okay, and if you put that on the test, move it to the right one, that's perfect. Okay, I'm just going to write down what it actually, like the mathematical one, which is a horizontal translation of +1 unit. Okay, but if you put moves to the right one space, that's good enough for me. Okay? And then this -4, what does that do to it? Okay. Exactly. You can write that down, shift it down 4 units. I'm going to write down vertical translation of -4 units. But again, if you write down, moves everything down 4 spaces, that's good enough. So tomorrow we're going to go over even and odd polynomials, which are